You, a grade 12 student, woke up to realize that you're already in grade 12 and you need to find a college soon. There are many choices to pick from, and yet for some reason, none of them seem to interest you in the slightest. Suddenly, it hits you in the head. You want a good quality education for the low price of free. Your only choice now is to aim for a scholarship. Apply for UP. As one of the top 4 universities in the Philippines, anyone would expect hundreds of thousands of applicants for the university every year for their world-class education. And of course, UP cannot accommodate everyone into the university, so one would need to devise some sort of test to see who will be the least waste of time to teach. UPCAT is UP's entrance examination that plays a large role in determining whether or not a student-selected course gets accepted by the university. In fact, it accounts for 60% of the student's calculated university predicted grade, which is the ranking parameter used by the university in displaying UPCAT results and in checking whether or not a student is eligible for the course. As for the other 40%, well, let's hope that you did your high school work pretty well. There is no problem with the system itself. The problem is that there are too many people wanting to apply for the university. Individually checking each and every single applicant manually would take so much time that by the time they finish checking them all, the succeeding UPCAT season would have already started. With that much paperwork, the staff would need to organize their data properly such that it's easier to sort them according to their UPG. So how can we help store all of the data required to be kept, along with the flexibility of being able to arrange them by the university predicted grade when the tests have been administered? We need to administer the use of an abstract data type, the linear list. The linear list is as you would expect it to be, a list that arranges the data in a linear fashion. But unlike the array, we can insert and delete nodes as we please. In other words, it's dynamic with using memory. It's like an office drawer. Each folder of paperwork is data and the drawer itself is the list. Now you're probably scratching your head, asking, why should we use a linear list in UPCAT processing? You see, the advantage of using a linear list is the ability to insert elements or rearrange them in increasing or decreasing order. We may have said that there's at least 100,000 people taking the test, but we're never really sure how many exactly there are. If we attempt to use an array, memory allocation would need to be specific. On the other hand, with the linear list, we can add new data as we please, including the latecomers who happen to finish their requirements 5 minutes before the deadline. There are 2 factors to be considered for UPCAT sorting: location and last name, though applicants only need to be sorted by their last name. As it is unsure how many applicants chose which testing center, a linear list is needed. With the linear list, it is only a matter of comparing the last names alphabetically and then changing the respective links for each node. For example, let's say that 3 friends who lived in Baguio, Juan, Dela, and Cruz, all applied to take the UPCAT in the testing center. Cruz did his forms early and was able to submit it first, while Juan came in a close second. A little later, Dela came in and submitted her forms. In dictionary order, Cruz comes first, then Dela, then Juan. Conveniently, we have the list arranged as Cruz, then Juan. For every new entry we add to the list, in this case Dela, we can use a sorting algorithm to insert her into the list based on the lexicographical order of her name. After that, the list will have been sorted for the 3 friends. This can be iterated over as many people as UP can take in for the UPCAT in any of the testing centers. As for how many applicants would be taking the UPCAT in a day, that's up to the capacities of the testing centers. A few textbooks, Red Bulls, and sleepless nights later, UPCAT season is finally over. Congratulations to everyone who managed to give it their best effort, even if you feel like you didn't. Now it's time for the anxiety-inducing results. This time, it's no longer a separated by test centers thing. It's now a question of what campus you choose to be in. As it was said in the UPCAT orientation, there is a cutoff grade for each campus. Not only that, but there are also your top 4 campus choices and your preferred courses under each campus. But of course, these are also solvable using linear lists. All elements can now be sorted by everyone's UPG, ranging from highest to lowest. In addition to this, once these UPG scores have been sorted, these can then be copied into smaller linked lists per campus, and then copied into even smaller linked lists per course from those, in order to ease the processing of documents. Since these lists have already been sorted by UPG score and categorized and subcategorized into campuses and courses respectively, this makes the rest of the process a lot smoother, as you would only need to process the requirements for a given campus course combination. This example showed how useful linked lists are when it comes to processing of the UPCAT, and how it would also be incredibly useful for any other problems of a similar vein, such as for job interviews. It also shows the simple yet powerful implementation and usage of its sorting and splitting functions, making it quite a versatile data structure to use for problems such as these. Now if it could only solve the problem of you needing to prepare for its grueling entrance exam.